Okay, this is where we were. This is what we got up to last time. We have basically a summary of the minimized Boolean equations, and I'd asked you to see if you could have a look at these and think about how you might implement these equations using gates. All right, let's see if we can have a go at this together. All right, before we actually look at the gate implementation, let's just come up with a basic block diagram for this system. So look, I'm going to draw a block here. This is going to be for our logic, in this case our gates. Let's just draw the outputs on this. So what we have here is the green LED, an output being for the red LED. We've got a siren output, we call it SR. We've got a reset. Now this reset is going to be used basically for my SR latch. We've got a clear function, LCLR, which is used to clear the counter for us. And then of course we've got our next state variables, AN, BN, and CN. Okay? All right. Let me show you the state variable flip-flops. So we've got 3 of them. So here they are, 1, 2, and 3. So this is D and Q, D, Q, D, and Q. All right, so this would be my input, A. Now you will note that there is a Q bar available to you as well, okay? So you really could have A bar coming from this state variable flip-flop here. Look, I'm not showing that on this diagram just because it tends to become a little bit too cluttered. So here is the B input, and then of course here is the C input. Our feedback, of course, our next state information is fed back to the inputs of these flip-flops like so. And like so. So that's our next state inputs into these flip-flops. Okay. Now look, it might be more convenient if I show you the counter, let's say, sitting over here. So I'm going to draw that here. So that's my counter. We've got an output from the counter, which is our CO output. So this is, let's say, CO. Which we're going to bring back over, and it will be an input to our state machine. And then of course an input to the counter really is this clear that we have over here. Okay, so let's show that carry out as an input into my state machine like so. All right, let me show you over here the SR latch, which is used to arm and disarm the system. So here it is. This is my S and R. It's got a Q output, and that is an input to our state machine, and that's our AD input into the state machine. All right, now as I indicated before, this could be used with some kind of a key switch, but nevertheless it's a switch. I'll model it this way. It might be a normally open switch such as this, and we are typically putting an AND gate like so. The output of the switch then is basically inverted. And so if this is a normally open switch, we don't want to, remember that logic level there is a 1, but we don't want to set this thing. That's why we've got the inverter sitting there. And as far as the reset is concerned, remember we're actually bringing a reset line down like so. So this is my reset. Let me show you that. I'll bring that all the way from right here. So if the reset is true, if reset is 1, then basically we're forcing S over here to be a 0. Okay, so that's the purpose of that inversion before we go into the AND gate. And then of course the reset comes in like so. We have our last input into this system, which of course is my intrusion input. Now where am I getting that from? Well, remember we discussed this before, and we could view this as a series of switches, each switch corresponding to a door or a window, and we're simply taking the output from here. So if all the switches are closed, that means all doors and windows are closed, then this intrusion input is a 0. If any one of these were to open up, this voltage goes up, becomes a logic level 1, and therefore we do have an intrusion. So look, that's our basic system. Now what we're going to do now is have a look at the gates for the logic. Remember, that could be implemented with a memory, but in this discussion we're going to just show you the gates. Okay, oh, one thing before we leave this, of course the system clock is attached to the state variable flip-flops and also to the counter. So it's really the same clock that's attached to the state variable flip-flops and the counter. Okay, let's have a look at how we'll implement AN. All right, so let me just draw this in a simple way. Let's supposing we have A, I'll just show this a wire for A, B, C. All right, let's see if we can implement this first product term. What else do we need here? Oh yes, of course I need the arm disarm as an input, so I'll show that here, AD, and of course I've also got my intrusion as an input like so. All right, so let's do this. It's 2 product terms, so we've got 2 gates to worry about here. So I'm going to show this by way of an AND gate. So this is my first AND gate that's sitting here like this. What have I got? Intrusion coming in, so I'm going to grab intrusion, I'm going to feed that in. What else? AD bar, so I'm going to grab AD, I'm going to bubble it. AD bar coming in. I've got A bar, so I'll grab A, bubble it, and then I've got what? B, and I've got C. All right, so there's my first product term. Next product term, so one more AND gate sitting over here like so. I've got CO bar, so here's, imagine I've got CO then, so this is CO, and I'm going to come in and simply invert it. Then I've got what? A, so let's grab A, there it is, A. Then I've got B bar, so there's B, and I'm going to bubble it to give me B bar, and then there is C bar, so here is C bubbled. All right, so I'm going to all those together, like so, and there is my AN, like that. All right. BN. All right, we've got 1, 2, 3 product terms. Let's do this. All right, first product term. Showed up by way of an AND gate sitting here. So here is my AND gate. What have I got? A bar, so A bar, B, and then C bar coming in. Next product term, I've got 1, 2, 3, 4, 5 inputs into it. Okay, so here it is. 5 inputs. So I've got intrusion bar, so I'm going to grab intrusion. There it is. Bubble it. I've got AD, so here is AD. I've got A bar, so grab A, invert. B bar, so grab B, invert, and then C. There is C. So that's my second product term. Third product term, here it is. I've got INT bar, so here's INT, grab it, invert it. I've got AD bar, so I'm going to grab this, going to invert. Then I've got what? A bar, so here is A, going to invert that. And then I've got B, so here is B. All right, so that's my third product term. We're simply going to OR these guys together, like so, and like so, and that is, of course, my BN. CN, 1, 2, 3 product terms. All right, first product term, here it is. Okay, A bar, so I'm going to grab A, invert, B, and C bar. That's my first product term. Next, INT bar, so it's another product term here, another gate, so it's INT here, and what? Inverting. Then I've got what? A bar, so here's A, invert it, and then I've got C bar, so here is C, and invert it. Here is my next product term. Last product term. It's my gate. What have I got? INT bar. So I'll grab INT, invert it. AD bar, so I'll grab AD, invert. And then I've got A bar, so here is A and invert. All right, I'm going to OR these guys together, like so. And then, of course, the output over here is CN. All right, green LED. Let's implement this. So what do we have? We have A bar, so I'm going to grab A, inversion, B bar, C. All right, so my AND gate sitting here, and that, of course, is my green LED. Red LED, okay, that's just what? A bar, so I'm going to grab A, invert, and B. So here is B. So that is my red LED. Siren, okay. So here it is. Siren, we have what? A. We have B bar. And we have C bar. And that is my siren. Reset, okay. We have A bar, so I'm going to grab A, invert, and we have C bar. And that is my reset. Am I clear? It's an OR function here, so I'm just going to grab an OR gate. I'm going to feed in what? A, coming into that OR gate. We've got B bar, so here is B bar, and then C bar. ORed together to produce LC, LR. So we've now figured out the actual gates that are used to actually implement this logic block over here. Now, if you wanted to draw a nice large diagram showing all of this with the actual gates, that could be quite useful to you. Anyway, I'll see you next time.